Algebra 1, we're in 12.4 doing a thing called Simplifying Radicals that you are going to do, I'm going to say, close to 1,000 times maybe before you graduate from high school. So this is a pretty important but not super complicated lesson. But it'd be kind of like in 7th grade if you zoned out on the day that you learned how to reduce fractions and you never reduced a fraction the rest of your high school career. You would have like 1,000 answers at least that your teachers would be criticizing because you reduced fractions constantly. Square roots constantly. You're going to need to do a thing called simplifying radicals. So here's the scheme. We need to find a perfect square that divides in. And this might be a list that you want to try to capture on a piece of paper somewhere once and refer back to through the chapter. I just made a list of numbers, 2 to 10, and then created what are called perfect squares by doing 2 times 2, 3 times 3, 4 times 4, 5 times 5, etc., and so forth all the way down. These are the kind of numbers today that are going to be our superstar numbers that we need to find something from this circled starred list that can divide into a number that we have. We're going to root these numbers. Rooting 25 makes 5. Rooting 36 makes 6. Rooting anything that's in the circle zone is going to make one of these from the first column. And that number is going to come out from inside a radical sign. And there's some other number from division that's going to stay in. So I'm going to take this idea and I'm going to walk left. But 4, 9, 16, 25, these superstar numbers need to be like in our mind or on a paper that we can peek at all lesson long. We're hoping that these numbers can divide into the numbers in the problem. So as I stroll left, if I think about, can any numbers from that circle zone go into 18? 9 can. 9 can go into that twice. So when I write my answer, I'm still going to have a radical with a 2 under it, because the fact that it went in twice just leaves me a 2 that's stuck. Okay, but the 9 is not stuck. 9 was on my list as a superstar, a perfect square. The 9, I'm going to do the root of it and bring out a 3. The square root of 9 is 3. This is multiplying this, just like when I write 3x, the 3 is multiplying x. When I write this 3, it's multiplying the root of 2. The root of 2 is a nuisance, because if you did try to do it on a calculator or something, it's a decimal that would never stop, never repeat. It'd be an irrational number, like pi is. So this is considered simpler because the radicand is smaller, to use a word from yesterday. The radicand is the number inside. So if you make the radicand smaller, that's considered a simpler problem. For 20, check the superstar list. The superstar list with 20, 4 goes into 20, and it goes in 5 times. 5 is not a superstar, so 5 is stuck inside. 4 was a superstar, so we square root it. The square root of 4 is a 2. For 32, there's a couple numbers that go into 32. If 4 does, and 16 does. And in this case, bigger will be better. It's like living in Texas. Find the bigger one that goes in. 16 goes into that twice. 2 is not a superstar. 16 is, so root the superstar. The root of 16, the root of any perfect square we want to do it, the root of 16 is a 4. 200, there's lots of numbers on that list that go into 200, grab the biggest one. The biggest one on that list that goes into 200 is 100. That leaves the 2 underneath, and then the square root of 100 brings me out a 10. 480. 480 has a couple friends on that list. The biggest one that would help us is 16. 16 would go into that 30 times. So 30 stays in. 16 rooted can bring out a 4. It's worth thinking about, just like reducing fractions is a fair analogy here. Sometimes you reduce and then you have to reduce again. It's worth thinking about whether any of the numbers on that list can help you with 30. And that answer is no, because I made the best first choice. But let me backtrack. If I made a worse choice in the beginning, something littler than 16, like 4. 4 goes into that 120 times. If we tried to leave under the 120 and root the 4 to make it 2, that's not bad, but that's not best. Because if we rethink, can anything go into 120 still from our superstar list? 4 goes into that 30 times. So we're back to the 30 that we knew was coming. The square root of 4 is a 2 that would like to be in front and would multiply the other 2. And we'd be back to the 4 that we had. This problem is going to do that. This is sort of like one that somebody simplified but didn't get the best answer. So for this, the 2 is multiplying. The 20 isn't the smallest radicand we can create. So we check our superstar list. And again, by superstar list, I'm talking about any of these numbers. We want to find one of these numbers that goes in. If it's not on this list, we don't care. We only care about numbers on this list. So if you're coming over here and you're thinking about like 2, 2's not on that list. We don't care. 10, 5, don't care, don't care. They're not on the list. We only care about numbers on the superstar list of perfect squares, which for 20, the only perfect square on that list that helps with 20 is 4. 4 goes into that 5 times. 5 is stuck inside because 5 is not a superstar. 4 changes. The superstars will always change by doing their roots. The square root of 4 is 2. Take that 2 and multiply the pre-existing number, and now there's a 4 out front. With 24, 4 helps us again. Goes in 6 times. So 6 is stuck inside. Square root of 4 is 2. Multiplies the number that's already in the front, and we get another 6. Coincidence that they were both 6s. Then we need another note. If I start to work some variables into the picture, for any even-powered variables, all you have to do is cut them in half. So if I throw you an x to the 6, you throw me back an x to the 3. Same idea as, like, the square root of 25 is 5, and I can prove that to you because this times this makes the original problem. X cubed times x cubed would make the original problem. So x cubed is the square root of x to the 6th. These have even powers again. So the x gets cut in half, the y gets cut in half. That's all we need to do for even powers. For odd powers, we need another note. For odd powers, we're still going to try to cut them in half, but it just doesn't quite work because there's an oddball 1 left over. So we're going to leave a radical sign around that still has 1 variable inside. So this x is an odd power, leave an x inside. This y has an odd power, leave a y inside. But other than that, we're looking to cut in half as best we can. Let me do this one first. Half of 7 is, at its closest, 3. 7 divided, we're cut in half, divide by 2, however you want to explain it. 7 divided by 2, 2 goes into 7 3 times. So a 3 came out. If we divide 2 into 3, that only goes once. So there's only 1 x coming out. I could write an invisible 1 here if I wanted, but the 1s are always there. And then I'll do variations on these themes. There's nothing new, it's just put together in a different way. So something like this, the x has an odd power. So an x needs to stay under there. The y has an even power, so y's don't need to stay under there. The y's can come out, so can some of the x's. Half of 4 is 2. Half of 7 is like 3.5. We'll worry about the 3 because we left 1 inside. For this one, let's do the number the way we were doing the numbers before. 18, we check our superstar list, and 9 is helpful. 9 goes into that twice. The 2 is not a superstar, so it's stuck inside. The 9 is a superstar, it brings us out a 3. The x has an even power, so no x's get stranded inside. We cut the 2 in half and bring out an x. The y has an odd power, so we leave a y in. There's also y's coming out. Half of 3 is like 1.5, so bring out 1, and then the other one was left in there. This next one, we have odd powers both ways. So there's an x stuck inside because x was odd. There's a y stuck inside because y is odd. But there's also x's and y's coming out. Half of 7, again, is 3-ish. Half of 5 is 2-ish. And for the number, do what we were doing in those first couple columns. Check our list. Can anyone help us with 12? Yeah, 4. 4 can help us with 12. 4 goes into 12 3 times. 3 is not a superstar, so it's stuck inside. The 4, we can root it, and it turns into a 2. For this last one, the x has an odd power, so for sure an x stays in. Half of 3 is 1 and some change, so an x comes out. With 72, there's a variety of numbers here that can go into 72, the biggest of which is 36. The figure will be better if you can find that first. If you didn't use 36 first, you'd have one of those problems where you'd have to go and then go again. But 2 is not a superstar, so it's stuck inside. The root of 36, we're just using this chart, to root the 36 turns it into its source number, which was a 6. Homework for this will be based out of page 505. 505, we're working, not starting at 1, because they did some weird stuff at the beginning, so we're just skipping those. We'll start at 8. So we're working from 8 to 31. It's pretty much like what I just did. One small difference I see on a couple problems that I'm peeking at now is every once in a while they threw a negative in the front, in which case you just throw a negative on the answer. So don't let that bother you. If you see any where they threw a negative at the beginning, just throw a negative on the answer, no big deal. But other than that, it looks like you have a pretty good mix of things based on what I was doing there. So, see you later.